Welcome to the MOOC for Digital Switching 1. This course actually I have been teaching in IIT Kanpur for a long time, but I have split it into two parts, and that is why the word Digital Switching 1, and there will be also a Digital Switching 2 sometimes later. So, here the emphasis is actually on describing the fundamentals, basically the theoretical foundations which goes into digital switching systems. So, for this lecture 1, basically the objective is why you require the switching systems, okay, and typically why you require digital switching systems. And as I think most of you must have already guessed it or must have discovered it, this has to do with the telephony, the whole system. So, basically how the telephone exchange or current day packet switching systems are actually do operate. When we will go to digital switching 2 sometimes later, maybe in another MOOC, that time we will talk about voice over IP systems. Most likely it will be SIP telephony, because that is what is now prevalent everywhere, and we will be talking about the complete signaling of that and how actually you work with those things. And we will be skipping out in digital switching 2 on circuit switching systems or telephone exchanges, what we call them now. So, basically the way I will start is everything has to start with communication. So, because humans do actually want communication provides an edge. If people communicate with each other, they can coordinate, and they are actually essentially the survival probability becomes better, and that is how the communication becomes very important, and it has been one of the main causative factors in the evolution of human beings. So, communication is one fundamental thing, and the whole digital switching systems is being derived basically out of it. Secondly, I have been talking about a word switching. So, how these two things are related? If communication has to happen, I talk and everybody listens, and that is a good way of communication, it is going to work. But we are talking about telecommunications, when people who are far off can actually communicate with each other, okay. So, how come the switching comes into picture? So, let us see. Switching fundamentally has to do with the world switch, which actually means you are going to modify your state. So, if you switch from one state to another state is for any system, state defines a condition in which will actually determine the input to output relationship. So, for me switching, for example, the most common switch which all of us come across is an electrical switch. Normally this is how we represent it, and if you connect a power source, so I have connected a battery, I can connect an electrical lamp, and this switch can have two states, on and off, and when you turn this on and off, that is what we call switching. But what you are switching here is a path for electrical power, because of which the lamp will either glow or will not glow. So, if I look into communication in switching, if I can somehow switch the communication paths, so if one person is speaking, so this guy is speaking, and I can actually have some mechanism by which this can either go to this person or this can either go to this person. I am actually doing a similar action on a communication path, and that is what the communication switching is all about. And when these signals which are passing through these communication paths are digital signals, we call them digital switching. So, that is how we define the digital switching systems. So, let us come to the networks, the fundamentals of this. We have to do with the communication. So, best thing, if you want to set up a communication system, so there is a person A, and this person A would like to talk to person B. So, I am now talking about how the communication can be set up among multiple people and how the switching will come into picture. So, I can actually set up a communication link between them. So, this guy can actually have a microphone, can actually have a speaker, and these two combined together, the voice can be recorded and played back. So, voice can go in this direction and voice can come in this direction. So, whatever this guy speaks is listened by this person and so on. So, I set up one link, there is no switching required. So, whenever this guy wants to talk, he will just talk, other person will listen. So, one to one communication, very good, there is no issue in this. So, but if you want to actually have a communication systems to be built, we need more number of users who should participate. So, power of communication only comes when you are able to communicate with anybody in the group. Okay. So, you may have to add more number of people. So, if I add another person, what we need? We need to create more communication links. If there are more people who are coming in, I need to create more communication paths. You keep on doing it and you will be able to satisfy the communication requirements, but outcome of this particular system is this mechanism is that if I have n number of users participating, I need to create large number of links. How many number of them? So, I will create, so if I have say 7 users, I need to create how many links? So, if you count, these will be 7 C2, 7 combinatorial 2, those many bidirectional links will be required for setting up a communication path between anybody to anybody. So, if the number of users is n here, so n is in this case is 7, so I will be requiring nc2 number of communication paths to be created, which turns out to be n into n minus 1 by 2. So, number of links which will be required will have a complexity of O n square. So, as n grows, the number of links required to set up a communication systems grows with n square. But this is not good enough. Even if you are willing to do this, let us look at what is going to be the utilization of every link. At any point of time, if it is a point to point communication, okay. So, one user is want to talk to other, so he will set up a path. So, one link gets occupied, but remember these two users will also get occupied who are talking to each other. So, in general, for every communication which is taking place, there will be 2 users which gets consumed. So, for n number of nodes, there can be n by 2 communications number of communications simultaneously which are happening. So, on an average, what is the utilization of a link? Utilization of a link actually means when link is being used for the communication to happen between person A to B, the 2 endpoints. If link is in use, it is in use. If it is not in use, its utilization is not happening at that point of time. So, what is the fraction of time for which utilization will happen? On an average, only n by 2 links can be in use. You cannot have more than that because all the users would be communicating in worst case, and n by 2 links will be in use. Number of links which are there is n into n minus 1 by 2. So, which actually means you will have a utilization u, I call it utilization, will be n by 2 number of links which are occupied and total number of links which are there, and this will be 1 over n minus 1. Now the problem here is if n grows, because we have large number of population and I think we need to set up a communication path for everybody. Everybody should be able to talk to anybody else, that is basically the objective. In limit, when n goes to infinity, your u, which is 1 over n minus 1, goes to 0. It is not a good design. So you are going to invest a huge amount of money in setting up the links and they are not going to be used. But you will say where the switching is happening. Now switching is actually happening at the nodes. So when somebody wants to talk to you, you actually select. You select which one of those gets connected to your audio player and audio recorder, okay, that particular system. So that is why you can make a voice call. This can be voice, video or whatever you want, but it is a communication path between two entities. But utilization is extremely bad. How to improve on this? Okay. So let us see how we can actually do the improvement. Only good thing is network is passive. Most of the switching functionality is pushed to the nodes. Now if I can actually accept another paradigm, I can be in far better situation. My worry is that I need to reduce this number of links. So one way of doing it is, let me have a small box. So I am now adding more complexity. This network was passive. There was only links, but now I am adding some component which is part of the network, and I connect the users here. And I connect them here. So how many links are required in this case? I will come to this box, what this box actually does. You require 7 links. So if there are n nodes or n users, you require n links. Now this box is going to be something special. We will talk about how this box actually operates. Okay, this is what we call actually a switch, and currently it is a analog switch because the communication will be analog. If you start transmitting digital signals over it, it will become a digital switch in that case. So it actually means it can set up paths between various nodes. If one would like to talk to 2, so it can set up a path between 1 to 2. If 3 wants to talk to 5, it can create a path like this. So it can create path between pairs, and it has the capability of doing this. So I am assuming, and we will look into this how we will implement this particular box. We call it a switch, or in telecom parlance we also call it an exchange, okay, but the generic word is switch. So for every communication I require 2 links to be occupied, and there can be at most n by 2 communications which can happen. Okay. So you will have total n links will be occupied in worst case if everybody is talking. So the pair wise all nodes are busy. So you will have n links occupied, available links are n. Your utilization in this case will be n by n, which is equal to 1. Even if n becomes very large, this remains 1. Only issue is, as my n actually grows, this device should be able to connect to those many number of links, and it should be able to create the connections between them. That capability has to be built in. So now the complexity has been removed from the network, has been actually moved to the network, while simplifying the number of links. Number of links have been reduced. It is not having complexity of O n square, it is having a now complexity of O of n. Number of links are actually equal to n here, but I am now making something which is much more complex, which is a switch. And there are of course issues with this switch, because the moment you implement this, how the switch will, how this device will know that which path has to be connected. So it means there has to be some mechanism by which this node can talk to this switch. So, in this case there was nothing like that, you just want to talk to somebody, choose that particular link and transmit. There was no signaling as such, you were just directly making communication path, only the endpoints were doing selecting the various links actually and connecting it to the source or sink device. In this case we have introduced something called signaling. I will talk about how signaling actually happens, an example in the manual telephony, and exactly same thing what happens in manual telephony will be replicated in electronics domain also. So, you have to first of all show, for example, to the switch your intention of making the call, that is needed. Switch has to tell you back, yes, you can actually make a call. Once that confirmation happens, you have to tell to whom I want to call, which number. So, once this information is there, it will set up that particular path, confirm back, and you will do the communication. That is extra overhead now which comes. Of course, I will lead to the utilization. So, you are going to reduce the cost here, because when you are going to lay this cable from a house to an exchange or a switch, you are going to incur certain cost. Here the cost would have been humongous, ON square. Utilization would have been very low, almost 0, which actually means the cost per user is going to be pretty large. In this case, the cost per user is almost fixed, because this length is fixed, if that is if it is within a small locality. So, you are going to now pay in this complication, in this implementation of this particular switch. Okay. So, this was realized almost long time back when telephony started, but there is still an issue. I am assuming that it is a small locality, the switch is there, these cables run say a few kilometer, not more than that, 1.5 kind of thing kilometers, which is fine. But suppose if you have to take care of the whole city, say whole country, will this architecture still suffice? I am going to make one single switch where everybody on within the city or within the country or within the state will be connected to. Now, some of these link lengths will be extremely large, and that is going to cost a lot. So, implication of this is, so if you have a switch, some people are very far off, some people are very close, the cost of these links are going to be pretty high. There is another problem now, how to solve this particular issue. I have got this particular topology, as it basically is a star, complexity in the switch, number of links will grow as the number of users will grow linearly. Same thing is happening here, but the link distances are pretty high. How to minimize on the cost, because this will cost a lot. Now, let us see how we can minimize on the cost. Now, as a user, are you going to talk for 24 hours complete day, all the time are you talking? Possibly not. Most likely you will be making a call to a friend, talking for some time, maybe for half an hour, at best 1 hour a day. So, people usually do not talk 24 hours. If they talk 24 hours, this link length is going to be justified. But if you are only talking for 1/24th of the day, 24 hours are there for 1 hour a day. So, for 23 hours you are still going to pay for the cost of this particular link. Its utilization is anyway 1/24. If it is only half an hour a day, it is 1/48. Now, can we do something? These links are smaller in length, their costs are small, so I can afford to have lower utilization. I can have utilization of 1/24th because of this time limit. So, in this case I cannot. So, one of the ways to actually solve this problem is using something called remote concentrator units, okay, which is pretty popular if an exchange, if you have to provide a connectivity to a remote village, how to do that. So, village is a cluster, So, everybody might have a phone, but putting up an exchange there specifically for that thing may be a resource consuming thing, it will actually cost something. So, idea is that wherever you have the locality, lot of clusters, so you set up something called a concentrator unit, connect each one of them with the short link. So, even these guys will get connected, so this link will not be there. So, all these are shorter lengths, but this is not a switch. What it does is, you are going to have so many small length links, you will create very few links all the way from here to here. So, if there are actually 1, 2, 3, 4, 5, 6, 7 users, but you have only 2 links here. So, when somebody from here want to talk to this guy, he has to talk to this remote concentrator unit, which will set up a path all the way back to the switch, and switch will set up a path between this device. In fact, now it is even possible because due to hardware thing that you can build up a even remote exchange nodes. So, path can be set up directly here itself. Okay. But what you are technically doing is, now these 2 long length links are being shared across 7 people. Earlier it was only 1 node. So, if all these 7 need to be connected here, they were required, we required 7 very long length links actually. Now we do not. So, this is RCU. In fact, we can actually move further. So, this can become an exchange if there too much of population is there, why not to use a remote concentrator unit. I can even deploy people, and then I can actually have another locality where there are many people. So, this is a natural extension, and what I get now here is these lines become trunk lines. So, trunk lines are the lines which will connect or interconnect the exchanges or the switches. The lines which actually connect the subscribers or the users to the switch are known as subscriber access part. Okay. So, subscriber access part, and this is known as the core part. So, normally the topology which will be there. Now, you can appreciate that this has been done for cost optimization. So, normally you will have switches, and there will be multiple paths, and then there will be users. Some switches will not have user. So, these kind of switches are known as access switches because people are connected to this. This is a transit switch. This switch is an access switch, as well as it is actually permitting the calls to also pass through from one exchange to another exchange. Through this, it is also a trunk exchange, is a trunk plus subscriber exchange. So, this is not actually passing the calls through it, but it is only actually passing the calls from subscriber to the network, then it is an access exchange actually. So, you have a core network. So, this is what becomes the core, and the remaining part become the subscriber network. So, that is how we actually define the thing. An important thing, these trunk lines are mostly long distance ones, and their utilization factor are kept to a very high value. So, we only add more links or more capacity only when it is required. So, the cost per unit per second of call on this is minimized. In fact, what happens nowadays is this cost is much less compared to the cost of the subscriber line. So, from exchange to your home, the line which is coming, its cost is much higher for per second call compared to a long distance STD link, because their utilization is being maintained at a very high level. Of course, you also create kind of interconnection, so that even if a switch fails, you can route the calls from other paths. So, trunk also provide reliability. Okay. So, in fact, technically if you look all these switches together, all subscribers are only at the edges of this distributed system. So, this is a single gigantic distributed switch, that is what is being created by using multiple of them. Okay. So, now the idea is that we will minimize on the cost as far as possible by actually using long distance link and maintaining the higher utilization for them. And for the subscriber links, these are short length links and their cost is going to be lower, so their utilization also can be lower. So, that is how the topology actually gets built. So, once this is clear, let us come to the manual telephony. Okay. So, how the manual telephony will look like? So, this will give us an idea about signaling. So, in manual telephony normally it will be humans which will be operating the exchange. So, I am not going to the intelligence in that switch. So, in the beginning itself people decided that we will actually have some humans operating them, because there were no computers, sophisticated computers or machines handling that. And typically how this exchange will look like, it will be nothing but there will be two boards. So, one where you will have the lights which will correspond to various users which are directly connected to this particular switch, and you will have connectors where actually jumper wire can actually be inserted, and there will be a human operator which will be operating this whole system. So, this will be connected to the phone instrument. So, currently I am not talking about the trunk kind of thing, I am talking about only one switch and all users connected to this. But when we will talk about signaling, we will also consider the communication between two exchanges also. So, that is the case which I will take. So, in this case whenever you will the power mostly is being fed from the switch, mostly through batteries. So, there is a cradle. So, when you lift this handset from the cradle, the circuit actually or a switch will operate here, and electrical path gets completed which will result into this bulb or indicator getting lighted up. So, this will remain there even when you are talking, this light will remain on until you are going to put the headset back to the cradle. So, that was the basic fundamental mechanism, and this is what is being used by the operator to figure out whether a user is busy or not busy. Okay. So, that is the idea which actually has been used. So, how for example a call will be made in this case? So, user mostly will lift the handset. So, once the handset is lifted, the electrical circuit will get completed which will result into this light coming up. Once this light comes up, the operator knows, yes, this guy probably wants to make a call. So, once the operator observes this, so there is a possibility that he or she might be busy in something else and she does not look at the light glowing up. You may have to wait for long time before she talks back to you. Your call will not get through in that case. Okay. So, once this light glows up, she will actually put up a headset, connect the wire to the point where the user is being connected, the wire is being laid, and once this connection is made, this user, this actually can respond back. So, most likely it is a message, welcome to so and so company and you would like to make a call. So, all kind of welcome message will be coming up, and of course, you can see the similarity to the current telephone communication which happens. So, once this happens, this guy will tell, I want to make a call. Call to whom? Remember when the manual telephony was there was nothing like switches here, there was no numeric keypads to dial the numbers. That interface came because of the automation. So, the person usually will tell, I want to talk to so and so gentleman at this particular address, and this address will be known to the operator. Operator will then find out, it will have a code book or a book which will be there. Using this, it will find out to whom the call has to be made. Okay. So, once it knows that where this guy is there, if this guy is this one, what has to be done? This guy has to be informed that somebody wants to call you, how that will be done. So, normally there will be an extension on this board. So, we will have special generators. So, I can have some kind of a music. So, if the jack is connected to this, you are connected to, you are actually going to listen to the music. There can be radio, there can be electrical power signal, a ringing current, an oscillating AC. So, she will actually inject this thing in the ringing current. She will actually take a jumper, conduct this ringing current, and then connect to this subscriber. The power signal will go there, which can actually then drive an electromagnet, which will cause the ringing to happen. Meanwhile, this guy actually can be, because she is busy in making up the connection. So, this guy can be connected to a music source, so that this guy knows that my call is going through as of now. So, probably this will be connected to a music source. So, this is a music source actually, this is a ringing current. So, ringing current is a power signal which can drive the bell on the other side of the phone. Okay. So, once that is done, so this ringing will happen, the user will now pick up the handset. Once the user picks up the handset, the light will glow here correspondingly. Phone will still keep on ringing, actually remember, phone will still keep on ringing, just removing the handset will not stop it. The operator will see the person has acknowledged, he has lifted the handset, she will remove this jumper. So, ringing current is no more being applied, she can connect her headset here and talk to the person, say so and so person is want to make a phone call to you. Now, remember this is something what happens in your caller ID. So, you get to know that who is calling you. So, once this person knows that who is calling me and is willing to accept the call, he will confirm. Once the confirmation happens, this will once the confirmation happens, she will actually take out this connector and will create a jumper between these two, and this music source will be disconnected. And once the jumper is done, the source and destination are connected together, and they can now talk, they can communicate, the call has been set up. But the moment the call is set up, she has to actually take, remember there was a routing table, or basically a table which says that which user is where. So, these are only numbers which are there, so which user maps to which number, okay, or it has to be routed to some other city, all that information is there in the routing table or address table. She also will have another register. When the call starts, she has to note down that who called, to whom the call was made, at what time the call started, and she has to keep on observing. When the light goes off, the call has been dismantled. When any one of them will put the handset back on the cradle, the light will go off. She has to figure out what is the closer time. Okay. Once the closer time is known, she will note down what is the closer time. We call this record as call detail record. And this is what actually can be used at the end of the month to generate the bill for the customer. So, but remember this is currently being done by a human operator, and he or she is prone to errors, making errors. She might have forgotten to close the call, she might have even forgotten to record the call itself, the call was made. So, there will be a billing loss in that case which will happen. She might actually do a misconnection, okay, or she is not in the good mood, she may not even look at the light and your call will not go through. Okay. So, now let us see if I extend it to a multiple exchange scenario, because this is not the network is something like this, how we will operate in this kind of scenario. So, it is a mere extension, let us see how it happens. So, if the user is here, connects to one exchange, this exchange is also connected to another exchange, now that is a network, and this can happen one after another, but I am actually assuming the other side user is here itself. Now there are two operators which are participating. Okay. So a similar procedure, the source will lift the handset, the light will glow up. Once the light glows up, the cradle handset is actually off the cradle. So she or he will figure out that there is a light glowing up, connect the headset, talk to the person, welcome, and then of course get the number. Same procedure what happened here, and then of course once that has been number has been received, she can actually put the music source here, this is disconnected. She now refers to a book which is a routing table book. This time the book does not tell that the destination is in the same city or connected to same switch, it is connected to some other entity, it is some other place, but she knows okay that place is connected to me, the next guy. So she will actually then put her headset into the path for the other exchange, and once that is done the light will glow here. So this operator now knows that there is a trunk call which probably wants to be set up. Okay. Once that is done, so this has to be connected to this connector. Now these two operators can talk to each other, and then he or she can transfer the destination information all the way to this person, and once that is done, this line will be kept on hold actually. Okay, this line is on because the other person has already put the connector here. She has to look into the book and find out where the destination is. Destination is at this point. So what will be done is, this will actually take out this headset and connect here. So this light is off now. So once this light is off, this actually operator knows that call is being currently in process of being set up. So she has to wait till this light comes back, and then this will this user, first of all before actually connecting this, will actually connect the ringing source so that this phone will ring, ringing current. Once the handset this is being lifted up, the light will glow. So she will stop the ringing current, connect her headset here, talk to the person, and if person acknowledges, then a jumper is being connected here. The moment jumper is connected, this light is on. The moment this light is on, she knows that call is through. In that case, she will actually then disconnect her stuff and then put a jumper here. The path is all through between source to destination. So if there are more number of switches in between, the same procedure is recursively followed. And then of course, once the call starts, she has to make the call detail record. So call detail record will again contain, this was the person who called, this call was a long distance call because it was sent to another exchange, and then of course it was started at this point of time, and source and destination both are there, and when the communication will stop, either this will actually put the headset back to the cradle, or this will put and the lights will go off. Once the lights actually goes off, in that case she will make the closer entry also. So, it is a source, destination, start and type of the call, which is the trunk. This is being recorded in a register. Again we call it a call detail register, which will be used again to do the billing at the end of the month. And of course, since it is a type of call is being specified, so bill for this will be different than the bill for the local call. So, that is how the calls used to get set up with a manual telephony exchanges. In fact, even now these are being used, but in a rudimentary fashion as a backup, but not in the commercial organization. These are only within the organization as ultimate last resort, okay. But mostly it is automated nowadays. So, in fact, when you look at this whole scenario which I have explained, you can see there was something equivalent of dial tone. So, welcome message being spoken by the operator, that is equivalent to dial tone. You were dialing numbers, that was like telling the address to the operator. She was putting you on the music till the time she talked to the so on and further to the other people, that is a hunting tone, that is the equivalent of that. Even now you get a hunting tone when the exchange is searching for the path. When the call is through, there is a ringing current, which also was there, it also happens nowadays. You do get a ringing tone, a ringing current actually, and additionally you actually the sender or the person who is calling, he is also being informed that there is a ringing is going on the other side. So, you are able to set up the call perfectly. And then of course, the caller ID. So, all of these were existing in some other form. But still there were problems in the manual telephony systems. So, what was those problems? So, problems with manual telephony were actually these, that you required people. That itself is a problem, because people's their mood actually changes, they can be angry, they can be upset, and they can forget the things. So, that was one fundamental problem itself. We wanted something reliable. There can be errors, it is an error prone system, errors in CDR, errors in connections, and of course, sometimes error in seeing the signals and henceforth not responding, okay, it is not the equipment failure. And of course, the worst thing, there is no privacy. So, if you want a privacy on these kind of systems when the communication has happened, so you should actually talk in the coded language, that is only privacy which you can maintain, otherwise there is no privacy. Operator actually can listen to the whatever is communication which is happening. And in fact, this is what led to the automatic telephone exchanges, and they goes by the name by A.B. Strouger. Okay. So, A.B. Strouger was underwriter, and of course, that time manual telephony was at its peak, and he was also, most of the time the people used to call the underwriters, and unfortunately where he was actually connected to an exchange, the operator there, her husband was also underwriter, and what has happened is all the business which was coming was being taken from the hands of Strouger to her husband, and Strouger actually lost, and that is when I think he decided that he need to solve the problem. And of course, with the help of other engineers, he came up with the idea of Strouger exchange. So, that was the first automatic exchange which came into picture. So, in the next lecture we will actually look into this Strowger thing, how actually the Strowger built up this stuff, and also look into how fundamentally the things actually have evolved from Strowger to the crossbar. So, we will meet, I will actually continue in the next lecture.